बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम। मैं उम्मीद करता हूँ आप सब लोग खैर आफियत से होंगे। हम 4th वीक में जो पढ़ने के लिए जा रहे हैं उसको दो हिस्सों में डिवाइड किया गया है, पार्ट 1 और लेक्चर 4 के पार्ट 2 के नाम से। हम अपने कंटेंट के नेक्स्ट चैप्टर को स्टार्ट कर रहे हैं। जो नेक्स्ट चैप्टर है हमारे पास कंटेंट का, उसमें हमें न्यूमेरिकल सॉल्यूशन ऑफ ऑर्डिनरी डिफरेंशियल इक्वेशंस के बारे में बात करनी है। तो बिफोर वी स्टार्ट developing those methods for the solution of ordinary numerical solution of ordinary differential equations, we must know some information. So that's why this lecture is designed in a way that first we will come to know about what actually differential equations are. Then different types of differential equations will be discussed. Then what does we mean by the solutions of differential equations, and then what actually we get from that solution, or what does we mean by different types of solution to the ordinary differential equation. Then there are two type of problems, so initial value and boundary value problems. For those problems we need two type of conditions which are named as इनिशियल कंडीशंस एंड बाउंड्री कंडीशंस। सो इन दोनों के दरमियान क्या डिफरेंस है, हम इसके मुतालिक बात करेंगे, और फिर इसकी मदद से जो इनिशियल और बाउंड्री वैल्यू प्रॉब्लम्स बनती हैं वो क्या हैं उनको डिस्कस करेंगे। देन चूँकि हम न्यूमेरिकल मेथड्स में न्यूमेरिकल सॉल्यूशन की तरफ जाएंगे तो हमें स्पेसिफिक टाइप ऑफ सॉल्यूशन की बात करनी है जिसे पॉइंट वाइज सॉल्यूशन बोलते हैं, और जो मेथड्स हैं उनकी डिफरेंट टाइप्स क्या है हम उसके बारे में बात करेंगे। सो हियर वी गो विद द फर्स्ट पार्ट, दैट इज डिफरेंशियल इक्वेशन. So here we mean from differential equation is ordinary differential equation. So we are not considering the partial differential equation here, since this is not the part of our course. An ordinary differential equation, simply called it ODE, is an equation containing one or more functions of one independent variable and one or more derivatives of those functions with respect to that one independent variable. So this term here, ordinary, is used in contrast with the term that we use in the case of partial differential equation. In that case we have more than one independent variable. So in general, given f, a function of xy and derivative of y, then an equation of the form function of independent variable, dependent variable, one or several derivatives of dependent variable with respect to independent variable is called, so since here is called ordinary differential equation. So there are two main types, explicit and implicit ordinary differential equation. So if this nth derivative can be separated on one side, then we call it as explicit ordinary differential equation. So whole equation can be expressed as form of one derivative. So more generally, implicit ordinary differential equations of order n takes the form this one. So you cannot separate yn on one side of the equation. So in that case we call that ordinary differential equation as implicit ordinary differential equation. So look at this example. Newton second law of motion, you know simple formula, F is equal to ma. So this is the term we are using here for the acceleration. So acceleration actually is the second derivative of the displacement. So if you will take the first derivative of the displacement, you will get the velocity, and then again another derivative of the velocity with respect to time will give you the acceleration. So this is written, the second law of motion is written in the form of a ordinary differential equation. So differential equations can describe nearly all systems that are undergoing some kind of change. They are used in science and engineering as well as economics, social science, biology, business, healthcare, and many other different branches. Many mathematicians have studied the nature of these different types of equations, and it has been done over centuries. And there are many well developed solution techniques to these ordinary differential equations. Often, these systems described by ordinary differential equations are so complex, or the system that they describe are very large. That's a purely analytical solution to that equation we cannot calculate. So for that case, when we cannot find that analytical solution to those equations, in that case, we want to approximate a solution to these systems. So it is in these complex systems where these computer simulations and numerical methods are useful. We'll be developing those techniques. So the techniques for solving differential equations based on numerical approximations were developed before programmable computers existed. So ये जो computers आज हम use कर रहे हैं programming different आप तो built in आपको different softwares different packages मिल जाते हैं for Mathematica है MATLAB है तो इनकी मदद से आप बहुत सारी चीज़ों को easily solve कर सकते हैं. लेकिन जब ये कंप्यूटर्स ऐसे नहीं एग्जिस्ट करते थे जिस पे हम ये सिस्टम्स कर सकते तो उससे पहले भी हम डिफरेंट न्यूमेरिकल मेथड्स डेवलप करके इनकी अप्रॉक्सीमेशंस कर रहे थे. सो ड्यूरिंग वर्ल्ड वॉर टू it was very common to find rooms of people, so these were usually women, who are working on mechanical calculators to numerically solve system of differential equations for military calculations. So different military movements and different strategies. So when they were discussing the change in the system, so these were modeled in the form of ordinary differential equations. So they were calculating all these and they were doing all that calculations during World War II when there were no programmable computers were available. So these all methods for solving these differential equations are very old one. So but now in current era we have this facility that we have so many different types of computers and program packages where we can program that numerical technique and we can find the solution to the systems with very easiness to us. So differential equations have different types. So I'll be discussing here those types which we will be going to use in our next part or as per our course outline. So first, linear differential equation. A differential equation is said to be linear if f can be written as a linear combination of the derivatives of y. So look at this form. So this one side explicit form, then the rest of the derivatives combination can be written in the form of this one, plus this is the right hand side, or we call that rx, that function we have on the right hand side. So where this cix and rx are the continuous function of x, the function rx is called the source term, and then leading to two further important classification. This r take us to the further classification. As I told you, this is on the right hand side, so you are very familiar with all these cases. On the right hand side, in certain equations you have zeros and in certain cases you don't have zero. So if rx is 0 and consequently 1, automatic solution, the trivial solution will be y is equal to 0. If you look at this equation, if rx is 0, so you have one trivial solution. 0 will satisfy this equation. So the solution of linear homogeneous equation is a complementary function denoted by y of c. So when right hand side is 0, we call this equation homogeneous, and the solution to that homogeneous equation is a complementary function, so denoted by yc. So c for complementary. But if Rx is not equal to 0, then in that case we have to find out, so this will be called non-homogeneous equation, and in that case the additional solution to the complementary function is needed. So we call that part of the solution as particular integral, and it is denoted by yp. The general solution to these linear equation can be written as the sum of complementary function and particular integral. So there is another type of differential equation which are known as non-linear differential equation. So the equation which will not be linear will be called as non-linear equation. Now discuss differential equation solutions. So given a differential equation is written in this form, implicit differential equation. So function f from I to R, I will be subset of real numbers. So from a function from I to R means the set of real number, is called a solution or integral curve for f. In f, that function is, if this function f is n times differentiable on that interval, that part means from it can be a subset of real numbers, so it can be an interval. So on that interval I, and f of this one means this f satisfy the given equation. So is equal to 0 means satisfy the original equation. So we call this f as solution. So a simple definition or the explanation can be, it should be a function, or a solution is a function from I to R if it satisfies the given ordinary differential equation. So since here we're using nth derivative, so that's why we're using that part as integral curve for f if f is n times differentiable. So the simplest definition can be, the solution is a function that satisfies the given ordinary differential equation. So it has different types, means, or we call the solutions a general solution of nth order equation if a solution contains n arbitrary independent constants of integration. So if equation is nth order and we have n arbitrary constant, so the solution which contains arbitrary constant is known as general solution. But in numerical analysis, we are not interested in general solution. Actually, we are interested in a solution at certain specific point. So that's why we have second type of solution, that is a particular solution. This solution is derived from the general solution by setting the constants to particular values. So if we have solution of the form c1 y1 plus c2 y2, this is called general solution. If in place of c1 and c2, which are arbitrary constants, I have some values, for example I say 2 y1 plus 3 y2, so this means this is a particular solution. So when the values, certain numerical values are assigned to these arbitrary constants in the general solution, so that solution is called particular solution of the ordinary differential equation. So often we choose to fulfill this set with the help of certain initial conditions or boundary conditions. So this will be, I will be explaining later what does we mean by initial conditions or a boundary condition. Since to find out the value for these arbitrary constant that we have in general solution, we need conditions. We need certain equations that can help us to solve that system and to get the values of these arbitrary constants. So here I want to mention one thing that you know from your basic knowledge of ordinary differential equation that you have studied as a compulsory course in your BS और एमएससी प्रोग्राम। अगर आपको याद हो तो हम किसी सोल्यूशन से मुराद ऐसा फंक्शन था जो ऑर्डिनरी डिफरेंशियल इक्वेशन को सेटिस्फाई करता था। उसके बाद उसका जनरल सोल्यूशन था, उसमें आर्बिट्रेरी कांस्टेंट्स आते थे और जितने डेरिवेटिव इन्वॉल्व होते थे उतने ही आर्बिट्रेरी कांस्टेंट्स आते थे, तो उसे जनरल सोल्यूशन बोलते हैं। हम इसका रिवर्स प्रोसेस क्या करते थे कि अगर हम सॉल्व करें यानी आर्बिट्रेरी कांस्टेंट आ जाए और वो गिवन इक्वेशन को सेटिस्फाई कर रहा हो तो वो उसका सोल्यूशन होगा। रिवर्स प्रोसेस हम क्या करते हैं कि अगर आर्बिट्रेरी कांस्टेंट्स को खत्म करके उनकी जगह पर डेरिवेटिव्स आए तो उसे बोलते हैं फॉर्मेशन ऑफ डिफरेंशियल इक्वेशन। सो सर्टेन टाइम्स पर हम डिफरेंशियल इक्वेशन जनरेट भी करते हैं, तो हम क्या करते हैं, जो आर्बिट्रेरी कांस्टेंट्स होते हैं तो उनको हम एलिमिनेट करते हैं। तो ये टू वेज बात ठीक है। अगर हम क्या करेंगे कि अगर मेरे पास फॉर एग्जांपल थर्ड ऑर्डर डिफरेंशियल इक्वेशन है तो उसका सोल्यूशन 3 आर्बिट्रेरी कांस्टेंट देगा। अदर वे अराउंड भी ऐसा ही होगा, अगर 3 आर्बिट्रेरी कांस्टेंट है तो मुझे इस इक्वेशन के 3 डेरिवेटिव लेने पड़ेंगे 1 2 3, ताकि मैं वो जो उसमें आर्बिट्रेरी कांस्टेंट 3 आ रहे हैं ABC या C1 C2 C3 उनको एलिमिनेट कर दूं, क्योंकि मुझे उसके लिए उतनी ही कंडीशंस चाहिए होंगी। तो इसलिए जितने हमारे पास आर्बिट्रेरी जितना ऑर्डर होता है ना इक्वेशन का उतने आर्बिट्रेरी कांस्टेंट्स आते हैं सोल्यूशन में, और अगर रिवर्स जाना हो जितने आर्बिट्रेरी कांस्टेंट्स हैं उतने डेरिवेटिव लेने पड़ते हैं आपको इक्वेशन जनरेट करने के लिए। और पर्टिकुलर सोल्यूशन में आपको याद होगा कि आप क्या करते थे, उतनी ही कंडीशंस आपको चाहिए होती हैं, the same number of conditions you need to find out the values of these arbitrary constants। तो वो जो आर्बिट्रेरी कांस्टेंट्स इंडिपेंडेंट कांस्टेंट्स आप निकालेंगे उसके लिए उतनी कंडीशंस चाहिए। तो पर्टिकुलर सॉल्यूशन निकालने के लिए आपको उतनी ही कंडीशंस चाहिए होती हैं जितने डेरिवेटिव्स होते हैं, इन अदर वर्ड्स उतने ही आर्बिट्रेरी कांस्टेंट्स होते हैं। तो जितने आर्बिट्रेरी कांस्टेंट उतनी कंडीशंस चाहिए, मतलब जितने ऑर्डर की डिफरेंशियल इक्वेशन है उतने ही आपको आर्बिट्रेरी कांस्टेंट्स मिलेंगे, मतलब उतनी ही कंडीशंस चाहिए होंगी पर्टिकुलर सॉल्यूशन फाइंड आउट करने के लिए। सो ये कंडीशंस को हम दो कैटेगरीज में डिवाइड करते हैं, इनके बारे में भी हम दोबारा बात करेंगे। सो आई वांट टू गिव यू वन ऑफ द असाइनमेंट। सो this is what we are talking about, solution of ordinary differential equation. So yet we haven't discussed numerical solution of ordinary differential equations. So since we are talking about the analytical solution to the ordinary differential equations, you have studied so many different methods to solve an ordinary differential equation, method of characteristics, comparing coefficients. There are so many different methods that you have studied in your ordinary differential equation course. That's a compulsory course for BS and MSc as well. So your assignment is you have to check for the result, a theorem that when the solution will exist and will this be unique, that solution to an ordinary differential equation. So you must have to get one results in what case the solution to an ordinary differential equation. So here solution don't mean numerical solution, I'm talking here about analytical solution. So you have to formulate the result, what when does the solution to ordinary differential equation, analytical solution to the ordinary differential equation will exist, and will this be unique? If not, under what condition it will be unique? So this is your assignment that you have to get that results. So no need to prove that result, but all the terminologies that are used in that results, you must go through those terminologies. You will not provide the proof to that theorem or any of the result that you will formulate for that case. So next, some definitions that you have studied already, but just to recall these definitions only. Differential equations are classified on the basis of their order. So what actually the order is? So order of a differential equation is the order of the highest derivative, also known as differential coefficient, present in the equation, whereas degree is what? Degree of a differential equation is represented by the power of the highest order derivative in the given differential equation. So आसान अल्फाज में मैं आपको बताता हूँ, ऑर्डर क्या होता है, किसी भी डिफरेंशियल इक्वेशन के अंदर जो सबसे बड़ा डेरिवेटिव यूज होता है वो उसका ऑर्डर कहलाता है, और सबसे बड़े डेरिवेटिव की जो पावर होती है वो डिग्री कहलाती है। ये आसान अल्फाज में डेफिनेशन। That's what I have written over here. So look at this example. d2y over dx square plus 2x dy over dx minus y is equal to 5x plus 1. So this is a non-homogeneous equation since we don't have Rx is equal to 0. So this is non-zero. So this is a non-homogeneous equation. So we have here second derivative. So it's second order ordinary differential equation. Its degree is 1 because here no power means it will be 1. So the highest derivative power is 1. So order is 2 since the highest derivative is 2 and its power is 1. So in this example it has order 2 degree 1. Look at the second example. Here we have third derivative. Look at all these derivatives. Again a non-homogeneous equation. So this is third derivative, highest derivative is the third one and it has power 2. So the order for that equation is 3 and degree is 2. Next we have what kind of equations actually we have to solve here. So the equations we are going to solve here in our course, first is linear differential equation. So linear differential equation, as I told you in the beginning, these which can be written as a linear combination of these y's. Another definition can be equation whose degree is 1. So its degree, it's not order. So it can have any derivative, but the highest derivative power will be 1. So we will be dealing these kind of equations in our course, the linear differential equations. First order differential equation means an equation which has order 1. So it can be written in this form. This is general notation for the first order differential equation. dy over dx plus p, it can be px because since they can be constants or can be functions. Pxy, but it cannot include this p cannot include y. So it should be a function of x or a function of independent variable, or it should be a constant. Similar case with the q. So we called this equation, or this is the general form of first order differential equation. So here p and q are either constant functions or functions of independent variables. Then higher order. So for equations, differential equations where order is 2 or greater than 2. So second order or higher than second order equations are known as higher order differential equations in general. So an equation which has order greater than 1. So if it is 2, then it is second order. If it is 3, then we call it third order differential equation, and general term we use for this is higher order. And then we come across another kind of equations that we called system of linear differential equation. So a system of differential equation which has first order linear equations, since it is a system of linear differential equation, it's a coupled system. So coupled system means what? Look at these equations. So first look this equation. dy over dx is 2y plus 2z and dz over dx is equal to x minus 9z. So this is a system. Y is with respect to dx, and similarly z is with respect to x. So these two derivatives, these are linear, is equal to some function of these two dependent variables. So y, z. So we can, it may include x, no problem, because independent variable we have no issue with the independent variables. It can come or maybe it don't come, no issue with that. If you look at the second equation, I have included that here. This is x minus 9z. So in simple words मैं आपको बताता हूँ. सिस्टम हमारे पास क्या है, एक डिपेंडेंट वेरिएबल का विद रिस्पेक्ट टू इंडिपेंडेंट वेरिएबल, और ये फंक्शन होगा किस किस का, ये y है, दूसरा डिपेंडेंट वेरिएबल क्या है, z है. तो f x y z, तो ये पहले का नाम अगर मैं f1 रखूँ फंक्शन, तो ये भी x y z का फंक्शन है, x इज मिसिंग, नो प्रॉब्लम. सो सिमिलरली ये भी एक्स वाई जी का फंक्शन हो सकता है। तो जनरल फॉर्म में आप इसको लिख सकते हैं डी वाई ओवर डी एक्स इज इक्वल टू एफ वन ऑफ एक्स वाई जी एंड डी जी ओवर डी एक्स इक्वल टू एफ टू ऑफ एक्स वाई जी। सो ये मैंने एक एग्जांपल लिखी है, ये सिस्टम ऑफ लीनियर जो है हमारे पास डिफरेंशियल इक्वेशन की एग्जांपल है। सो इफ यू लुक हियर in first equation to find y you need the information of z. In the similar case, in that case you don't need y, but this z answer which we will calculate from here we needed here. So that's why जो system है हमारे पास हम इसको coupled बोलते हैं कि एक की value दूसरे में use होती है। Since knowledge of z is required in order to find y, and likewise the knowledge of y in that specific case why we don't need the knowledge of y, but it can be here y or some other term. In that case we'll need the knowledge of y to find this z. Not in this case, but in general we can need that solution or the actually the information. So that's why we call this as coupled system. What actually we do? So we'll come across, as I told you, three different type of problems: first order, higher order, and system of differential equations. So if we have higher order differential equations, so how we will deal those differential equations? So the method that is used in the case of higher order differential equation is reduction of order. We convert higher order differential equation into the form of system of first order ordinary differential equations for our easiness. So हम जो हमारे पास हायर ऑर्डर डिफरेंशियल इक्वेशंस हैं उनको एक मेथड से जिसे रिडक्शन ऑफ ऑर्डर बोलते हैं, उस मेथड की मदद से सिस्टम ऑफ लीनियर ऑर्डिनरी डिफरेंशियल इक्वेशन में कन्वर्ट कर सकते हैं। और जो सबसे इम्पोर्टेंट बात है मैं आपको बताऊं कि अगर हम जो टेक्निक्स या मेथड्स डेवलप करेंगे, अगर हमें लीनियर डिफरेंशियल इक्वेशन सॉल्व करना आती है तो ऑन द सेम पैटर्न वी कैन सॉल्व सिस्टम ऑफ लीनियर डिफरेंशियल इक्वेशन। और हायर ऑर्डर तो सॉल्व हो ही सकती है क्योंकि हायर ऑर्डर को हम सिस्टम ऑफ लीनियर डिफरेंशियल इक्वेशन में सॉल्व कर लेंगे। इसलिए हम जो मेथड डेवलप करेंगे ना वो सिर्फ फर्स्ट ऑर्डर के लिए करेंगे और उनको हम वैसे ही यूटिलाइज कर सकते हैं। सो लुक हियर, can be solved easily these equations if the order of equation can be reduced. So any explicit differential equation explicit can be written in this form. So this can be written as a system of n first order differential equation by defining a new family of unknown functions for I 1 to n. The n dimension system of first order coupled differential equation is then, look at this equation. I simply tell you one example. So if we have d2y over dx plus dy over dx plus y is equal to x, in that case you have second derivative, first derivative, y, and then some function on the right hand side. So if we replaced first derivative with the new variable, so what will be the case? That's what we are doing here. So we are replacing the first, means since we are just making it in the form of system, that's why we're using variable y1. So y is equal to y1. Forget about the first line, look at the second line. First derivative is replaced as new variable. So when first derivative will be replaced as new variable, so this will become function of what? X, y, and this is new variable. So for symmetry we are using x, this y is equal to y1, so this y1 derivative will be actually new variable, we called it y2, and this is the second derivative, we'll replace this one with another variable. Look here, we are replacing all these derivatives, so you will get f of x, y1, y2 up to yn. So all will be means will be having n new variables from 1 to n for that case, and then we have independent variable x. So this will be converted, this nth order differential equation will be converted into n by n system of first order differential equation. So you will get n first order differential equation, coupled differential equation from n order differential equation. So higher order को हम reduction of order करके उतने सिस्टम में कन्वर्ट कर लेंगे. सो अगर हमारे पास सेकंड ऑर्डर है तो वो 2 फर्स्ट ऑर्डर में चेंज हो जाएगी, कपल्ड सिस्टम बन जाएगा. थर्ड ऑर्डर है तो 3 में चेंज हो जाएगी. So higher order can be converted to the linear system and system can be solved similarly as first order linear equation, जैसे मैंने शुरू में बताया. So we will develop methods for first order linear differential equations only in our case, because on the same lines we can solve system and higher order as well, since higher order is converted into the system of linear differential equations. Now, conditions for numerical solutions. You need conditions, since you need a particular solution at a specific point. So there are two types of conditions: initial and the boundary condition. Information from which a given set of mathematical equations or physical systems evolves are called conditions. In differential equation, these are divided into two parts as initial and boundary, and we need these conditions when we have to find particular and of course numerical solution to an ordinary differential equation. Initial conditions, we generally write them ICs. So ICs are the conditions given at the initial point of the system. From name it's very clear, given at the initial point of the system. In other words, if all the conditions given are at the same point, then these conditions are called initial conditions. On contrast, the boundary conditions are the conditions that are provided at the boundary point. So if we are talking about the boundary point, means there will be more than one. So in other words, if all the conditions given are not at the same point, then these conditions are called boundary conditions. So look at the example. It will make you clear all the things. For example, if condition for we have a second order differential equation, and for second order differential equation you need two conditions. If conditions are given in the form of y of a is alpha and y dash of a is theta, look here, both the conditions are given at the same point, a here, so that's why we called it initial conditions. But if you look at these conditions, if second order differential equation is given with these conditions, we call them boundary conditions. What? A and here B, so they are two different points, means the boundary points. So when these two are different, we call boundary condition. When these two are same, we call it as initial condition. So on the similar lines, we define the problems as initial value problems, IPs and BVPs. So differential equation along with initial condition is called initial value problem, and the differential equation along with boundary condition is called boundary value problem. So example, following is the initial variable. So look at this is the second order differential equation, means you will having two arbitrary constants, so you need at least two conditions. So if these conditions are along with these differential equations provided, y0 is 1 and y dash 0 is 1, so this independent point variables point is same, so we called it as initial value problem. So if you look here, these are not the initial condition, these are the boundary conditions provided at 0 and 1. These are two different points. So these equations together with this differential equation is known as boundary value problem. So a boundary value problem, this is the second order equation. And let's consider here first order differential equation. If we have first order differential equation, then how many arbitrary constants we need? Only one. So in case of first order differential equation, we can't have boundary value problem, because for first order differential equation you just need only one condition. Since you have one derivative, you have one arbitrary constant, you need only one condition. So for BVP, a system must start at least from second order differential equation. So a BVP is a second order or higher order differential equation, since a first order differential equation needs only one condition and hence only IVP. So जो बाउंड्री वैल्यू प्रॉब्लम्स हैं हमारे पास वो सेकंड ऑर्डर से शुरू होंगी, क्योंकि फर्स्ट ऑर्डर हमेशा इनिशियल वैल्यू होंगी, एक ही कंडीशन चाहिए होगी तो अंदर वाले पॉइंट्स डिफरेंट हो ही नहीं सकते, कंडीशंस ही एक है. सो सेकंड या हायर ऑर्डर डिफरेंशियल इक्वेशंस जो हैं उनको वो आईवीपी भी हो सकती हैं और किसी भी टाइप की हो सकती हैं. सो लुक हियर, ये हायर ऑर्डर है, ये जरूरी नहीं कि सिर्फ फर्स्ट ऑर्डर में आईवीपी होना है, हायर ऑर्डर भी आईवीपी हो सकती है अगर कंडीशंस इनिशियल हों तो. नाउ we are talking about point-wise solution, and different methods types will be coming across in our this course. In numerical method, we approximate a particular solution to the given differential equation along with given conditions. So means this is a numerical solution, so we have to find out the value of y at certain value of x. So we find numerical value of y1, y2, y3, so on many different values of y at different points corresponding to the independent variable values. Means this y1 is corresponding to x1, y2 is corresponding to x2, and y3 is corresponding to x3, so on. So that the ordered pairs, these are the ordered pairs, satisfy a pre-assigned particular solution, and this type of solution is called point-wise solution, because for x1 you will get the value of y1, so each point you are getting the answer to different points. So in general, when we talk about the solution, so solutions mean a function, so function is everywhere, but in numerical case we are more interested in point-wise solution, means to find out the value of dependent variable at some point of independent variable. So at different points we are calculating the solution, that's why we call it a point-wise solution. So we'll be interested in point-wise solutions. So as a mistake, it should be here. We will study two types of methods in our course, single step methods and the multi-step methods. So what are single step methods? So single step methods are the methods in which to compute next iteration we need only previous iteration. So we'll be discussing Euler methods. You will come across the Euler method. It's a means अगर हमें किसी क्वेश्चन को सॉल्व करने के लिए जो हम मेथड अप्लाई कर रहे हैं, वो मेथड एक वैल्यू फाइंड आउट करने के लिए सिर्फ प्रीवियस एक वैल्यू यूज करे, यानी अगर मैंने yn निकालना है तो सिर्फ yn-1 यूज करे, जरूरी नहीं yn-2 करे, सिर्फ एक करे. अगर प्रीवियस एक इंफॉर्मेशन यूज करें तो उसे बोलते हैं सिंगल स्टेप मेथड्स. इसकी एग्जांपल आयलर मेथड अभी हम देखेंगे आगे जाके. अगर वो एक से ज्यादा यूज करें, सो वेयर एज मल्टी स्टेप्स मेथड्स आर द मेथड्स इन विच टू कंप्यूट नेक्स्ट आइटरेशन वी नीड मोर देन वन प्रीवियस आइटरेशंस. एक से ज्यादा, तो ये हम प्रेडिक्टर करेक्टर मेथड्स देखेंगे, उनमें एक से ज्यादा इंफॉर्मेशन हमें चाहिए होगी एक आइटरेशन को कंप्यूट करने के लिए, तो उन्हें बोलते हैं मल्टी स्टेप मेथड्स. तो हम दो मेथड्स के क्रॉस आएंगे यहाँ पर अपने कोर्स के अंदर. सिंगल स्टेप मेथड्स भी पढ़ेंगे और मल्टी स्टेप मेथड्स भी पढ़ेंगे. सो थैंक यू वेरी मच. दिस इज द इंफॉर्मेशन दैट यू हैव ऑलरेडी. So if you have any question, you can contact me through these provided links. I hope you have understand all the things, but still if there are any questions, so you can contact me through these available links, and I will be at your disposal. Thank you very much. Assalamu alaikum. Allah Hafiz.